Good morning students, this is Sheba. Now we are going to discuss about the signals and systems, Unit 1, classification of signals and systems. In our previous sessions, we have discussed about the basic elementary signals, operations of signals, classification of signals. Now we are going to discuss about the system, an entirely different part from signals. So why we need system? What is the purpose of using this system? See, if you are taking a signal, you are going to use it for processing. We need to process the signal, we need to analyze the signal and find its parameters. Then only we can use it for our application. So, in order to do that, we need a device to process the signal. System is such device that processes the input signal to produce the output signal. A system is a combination of elements that manipulates one or more signals to accomplish a function and produce some output. You can see clearly here, system, it gets the input signal and produces the output signal. Moving to the example of some of the systems, a circuit involving a capacitor can be viewed as a system that transforms the source voltage to the voltage across the capacitor. A communication system is generally composed of three subsystems like a transmitter, channel and receiver. Channel typically attenuates and adds noise to the transmitter signal, which must be processed by the receiver. Biomedical system resulting in biomedical signal processing. Control systems are also used for controlling the functions. You can see an example of RL series circuit. Using a first order equation, VL of t is equal to L into di of t divided by dt. Here, V of t output is equal to VR plus VL of t. That is I of t into R plus L into di of t divided by dt. It is a closed loop system which you can clearly see. Mathematical modeling of continuous time systems represent how continuous signals are transformed via differential equations. For example, the RC circuit. Here, difference equations like dVc of t divided by dt plus 1 by RC into Vc of t is equal to 1 by RC into Vs of t, where system indicating core velocity can also be depicted by using the mathematical modeling m of dV of t divided by dt plus rho into V of t is equal to f of t. Most discrete time systems represent how discrete signals are transformed via difference equations. For example, bank account, discrete core velocity system, etc. Order of the system. What is this order? Order of the continuous time system is the highest power of the derivative associated with the output in the differential equation. For example, m into dV of t by dt plus rho into V of t is equal to f of t. Here order is 1. The order of discrete time system is the highest number in the difference equation by which the output is delayed. You can see here y of n is equal to 1.01 into y of n minus 1 plus x of n. So output is delayed by 1. So value here order is 1. Interconnected system. There are also many interconnected systems like parallel system, series, cascaded system, feedback systems, which you can see in the diagram. So, for example of interconnected system, consider a system with 4 subsystems. You can see in the diagram given below. Each subsystem transforms its input signal and the result will be consecutive or summation of total output produced by each subsystem. That is y of t is the total output, which is equal to y4 of t into y5 of t. This is equal to t3 into t1 of x of t plus t2 into x of t into t4 into x of t. Feedback system is nothing but it is used in automatic controlling. Like you can see here, controller, plant, sensors are interconnected and feedback is given from the output plant. If it is satisfied, the output will be produced, or else again it is again recycled. There are also many types of systems which is said to be the classification of system, which plays a major role in our signals processing, like causal and non-causal, anti-causal systems, linear and non-linear systems, time variant and time invariant systems, stable and unstable systems, static and dynamic system, invertible and non-invertible systems. Causal and non-causal. Causal is nothing but if the present value of the output signal depends only on present and past values of the input signal. That is, y of n is equal to x of n plus 1 by 2 into x of n minus 1. Whereas on the other condition, it is said to be non-causal. That is, if present value of output depends only on the future value of the input signal. That is, y of n is equal to x of n plus 1 plus 1 by 2 into x of n minus 1. Moving to the next one, linear and non-linear system. A system is said to be linear if it satisfies the principle of superposition. That is, for checking linearity, first we need to check the response due to linear combination of input. Then we combine the two outputs linearly in the same manner as the inputs and combine, and again total response is checked. If both are same, then it is said to be linear system. Otherwise it is said to be non-linear. Time variant and time invariant systems. So time invariant, from the name itself you can say it invariant, it does not varies with time. Whereas time variant, it depends on the time duration and varies according to the time period we are choosing. Stable and unstable system. A system is said to be stable if its bounded input produces bounded output. That is BIBO stable. BIBO, bounded input, bounded output. That is, if every bounded input results in bounded output. So its value must be less than infinity. Here you can see the example of stable and unstable system. The system represented by y of t is equal to a into x of t is unstable because the value of a may be greater than 1, also greater than infinity. We doesn't know the value. So reason, let us assume that x of t is equal to u of t. Then at every instant of u of t will keep on multiplying with a, and hence it will not be bounded. Moving to static and dynamic systems. A static system is static, fixed. So it doesn't need any memory. It is a memoryless system. It has no storage devices also. Its output signal depends on the present value of the input signal. For example, I of t is equal to 1 by r into v of t. Dynamic system. A dynamic system is nothing but dynamic. It varies based on the input you give. So it possesses memory. It has the storage devices. A system is said to possess memory if its output signal depends on the past value and future value of input signal. So I of t here is equal to 1 by L into integral of minus infinity to v of tau into d tau, and y of n is equal to x of n plus x of n minus 1. So here it depends on past as well as the future values also. So example of static or dynamic, you can see the circuit given. Here source V1 of t is given and RC is connected. Output is taken across the V2 of t. So here whether it is static or dynamic, the system here shown is RC circuit, that we can see clearly from the diagram. R is memoryless and C is a memory device. You know the capacitor, it stores charge, because of which voltage across it can't change immediately. So hence the system is dynamic or memory system. Since capacity is a memory device, it stores the data. Next, moving to invertible and non-invertible inverse system. If a system is invertible, it has inverse system. That is, the output, from the output again input can be achieved. Whereas if it cannot be achieved, then it is said to be non-invertible system. Next, LTA, linear time invariant systems, are completely characterized by its unit sample response. That is, the output of any LTA system is a convolution of the input signal with the unit impulse response. That is, y of n is equal to x of n convolution h of n. That is, summation k is equal to minus infinity to infinite x of k into h of n minus k. There are also some properties of convolution like commutative, distributive, associative properties. And also major properties of discrete time LTA systems, linear time invariant systems, like causality, stability has to be satisfied for certain conditions to occur. Moving to the important questions from this topic which we have discussed. Causality, stability, static dynamic conditions need to be known clearly, and also they may be asked in part B and part C as you need to derive the classification of all these systems based on the given problem. Moving to the important links for reference. Here I have also given the website reference as well as the book reference. Dr. J.S. Chittoor, Signals and Systems, page number 69 to 82 of chapter 1 corresponds to the content which we have seen now. Moving to the real-time applications of this signals and systems, as I have said in the introduction part, this is applied in many communication, speech and audio processing, multimedia processing, image and video both, underwater acoustic communication, biological signal analysis, that is in medical field also. So our signal and system analysis is implemented, and it is an inevitable thing in the real-time technological world. Hope from this unit 1 you have got a clear knowledge about the classification of signals and systems. If you have any doubts in this, you can ask me and get the details. Thank you.